Yes. Hello. Testing 1, 2. Okay, good morning, everyone. Hopefully you will survive from the weekend. Please try this tutorial I gave you. If you get stuck, just send me a message. Yeah, start with the question. Okay, please try to do the question tutorial. So that some of you send me some question, quite good. If I see there's some technicality that everyone should know, then I will share in front of class. So for example, let's start with an warm-up example. So I realized that maybe sometimes it's hard to find what's the domain you need to find for integration to find the area. Okay. In particular, you want to find the intersection point. Okay, so what angle you need to pick, right? Yeah. So for example, I won't give you a full area question yet. So let's find, for example, find all theta such that uh, for yeah, let me switch this question for r equal to sine 2 theta. Find all theta such that r equals 0. Okay. Try and work out how many theta that satisfy this equation. Sorry, r equal to 1. Okay. Let's say we want r equal to 1. Okay. Try and work out this question. Yeah. Now you can discuss with your friend. After 3 minutes, we will talk again. Try and discuss with your friend. When r equals to 1, how many theta? So this theta, I want it to be in between 0 and 2 pi. So inside a full circle, how many times this equation equal to 1? This week we still got new friends coming in. Anyone is the new to this class today? You? Okay. You? Okay. You can refer to the notes and recording in the Moodle on our past lecture. Who is Yamei then? Is it called Yamei? Let me check. Yeah, one Yamei. One Yamei. Not here yet. One Yamei. Okay. So how many theta have you found? Any of you? 2? Well, okay. Wait first. So 2, how many? You can tell me what's the two. Pi over 4 and 5 pi over 4. Okay, so what are these? After you apply the 2 theta, you get pi over 2 and 5 pi over 2. Good. Okay, so how do you get this answer? Can you share to us? Okay, you sketch good. Okay, I thought you were going to tell me I get from the calculator. So you sketch the 2 pi, right? Okay. So we start at 2 pi because we only care about up to 2 pi. After 2 pi, we keep repeating the diagram already. So we only care about 0 to 2 pi range. So you mean you get this pi over 2 and this one 5 pi over 2. Oh, sorry, pi over 4 and 5 pi over 4. Okay, good. Okay, so this is the first good sign. So you use graph instead of calculator. So if you use calculator, I'm not sure how many answers you get. Anyone use calculator? What, you use calculator? Okay. Anyone of you use calculator? No. Okay. Okay. So this is the most primitive way to do it. Okay, which is good. So you get 2. So you said you got 4, right? No? You sure it's 2? Okay. But the answer is 4. So why is it 4? Okay. So next, of course, here is I equals to 1, right? Okay, here is I equals to 1. But you still have minus 1 here. Okay. So where does this point get minus 1? 3 pi over 4 and 7 pi over 4. Okay. So let's write down this point. Okay. So this point is what? Minus 1, 3 pi over 4 and minus 1, 7 pi over 4. Okay. All right. So where does this point lies? So where's 3 pi over 4? So 3 pi over 4 should be somewhere here between pi and pi over 2. Okay. But you take minus 1. So you go to the fourth quadrant. Minus 1, 3 pi over 4. Here is 1, 3 pi over 4. Okay, hopefully you should still remember. So you take negative radius, you go to the opposite quadrant. Okay. So how to express this? How to express this in terms of positive radius? You need to measure the angle all the way from 0. Right? So what's the angle here? What's the angle here? How to get this angle? How to get this? 2 pi, you show 2 pi minus. Okay, so okay, let me try. So here is 3 pi over 4, right? Okay, so what's the basic angle on this side here? 4. Okay, so this means here is pi over 4. So to get the angle starting from 0, you need to take 2 pi minus pi over 4. Okay. So this point is equal to minus 1 and 2 pi minus pi over 4. Okay, which is 7 pi over 4. So minus 1, 3 pi over 4 is really 1, 7 pi over 4. Okay, so you also can compute, so you can try and compute the same way you will get 1, 3 pi over 4 for this guy. Okay. Okay, and then you can see that this 2 point is really different from this 2 point here. Okay, although they all get sent to 1. So you got what? What you say? Confusing. Um, yeah. So you got 4 points here. Okay, 4 different points here with radius 1. Okay. So why is it actually the first way I think about this question is if you put into the polar coordinate, right? You really only care about radius 1. Okay, meaning the the length is 1. Okay, I don't care is positive 1 or negative 1. Okay, because positive, negative give you direction. But when I ask about radius 1, right, I only think about length 1. Okay, so automatically you need to consider the -1 guy. Okay, and then it turns out that they are really a different point. Okay, it turns out that they're really different. Can you see it? Okay. So you need to compare when they are radius 1. They are really different. So for example, what do you mean? What do I mean by they are the same? So if I add 2 pi to any of them, so for example, I add 2 pi to power 4, okay, which I get uh what do I get? 9 pi over 4. Okay. Then 9 pi over 4 is one of these points. Okay. You get what I mean? So we only identify point that is 2 pi away. Okay. So let me put it down. So remark in polar coordinate, we identify theta and theta plus 2 pi. Okay. But these 4 points are not 2 pi from each other. So they are different. Okay. They are all different points in 0 to 2 pi. Okay. Make sense or not? Any question? And please don't be shy in asking questions. You are adult now, so you should communicate. Okay. There's nothing for you to shy. Okay? If you don't, so for lecture, right? For lecture is you build connection with me. So individually you build connection with me. If you are not happy with me, if you don't understand me, so you should talk to me. Any question? No? If you don't want to talk in front of the class, you also can message me. Okay. There's a lot of way to approach me. Any add on? I want to try and say something conceptual. Okay. Either you get it, if you don't get it, you can think about it, and then after class you can talk to me. So I thought about this I think for 1 week already. I think I want to say it out. Yeah, remember we have this example here. Remember how we described the circle center at 0 with radius 1 in terms of xy? S squared plus y squared equals to 1. Okay? And we also say that this can be expressed as r equals to 1. Right? Right. So if we translate it to here, wait, what? Oh, what happened? Let me re-share. Let me re-share. Okay, so but when we draw into r over theta, we have a whole real line, right? Is that right? Last time we saw this. Okay, and then we also mentioned that actually, you just take 0 to 2 pi, then this 0 and 2 pi will wrap around the circles once, right? Is that right? Okay, so if you imagine our xy plane get filled with this circle here, right? Different radius, okay? We really just need this part of line. We can fill the whole xy plane. So you can see that we got so many excess of point in this plane when we want to describe xy plane in our theta uh, plane. Okay, make sense? Make sense or not? Okay, if this doesn't make sense, never mind, but please think about it. So I repeat again. So xy plane, okay, we can express every point in xy in terms of some point in the circle, okay? And then we also say that we only need the graph from 0 to 2 pi to express all the circle here, okay? In particular, all the positive radius, because all points are positive distance away from the origin, okay? So what about this part here? How about this part here? What happened to this part? Okay, actually we identify them with all the point in this blue region here. Okay, so we identify the negative radius between 0 and 2 pi with the positive radius 0 and 2 pi, and away from 2 pi, we identify them back to this blue region here. Okay, so this means that actually r theta plane is much bigger than xy plane. Okay, because we can express everything in the xy plane using the point just in the blue region here. Okay, please remember my word and think about it. Okay, if you don't understand, you're still struggling to understand, you can come and talk to me. Okay, for the rest, if you understand, mm, you can help your friend. So far, have any question to this? Other thing outside in the yes. We use identification, 2 pi identification. Okay. Yeah, so this is also another reason. Um, this is also another reason that I don't really talk much about this polar here. Okay, because if you use the polar axis, so your angle is keep going on, going on, going on, right? And then your polar axis can go the other side as well. Okay, so in your mind, you should identify some point together. Okay, so you should identify theta. In particular, you should identify theta and theta plus 2 pi, okay? And for minus r theta, you should need to do some work. Find what you need to identify, okay? Okay, so in the polar coordinate, you get more points. And if you don't get what I said, please think about it. Okay, please think about it when you do exercises. But for this class, you need to know how to do exercises. Okay. If you do more, try think about this idea more. Okay. So then you will differentiate why is it better to use polar? Why is it better to use XY plane? Okay, all right. Any question? No? Uh, please don't give up understanding, because this is the only time you have for studying. Okay, if you go out and work, right, there's no much time for you to study anymore. You just have to give. There's less time for you to take it. Okay, so this is the most precious time for you to gain information. When you go out to work, you only give everything you have. Okay. All right. So let's return to what we left last time. Please keep sending me exercise, right? So it's like when you are in primary, secondary, right? You will hand in your workbook for teacher to mark, right? But when you are in university, you can do yourself. When you have problem, you can't find me. Okay. So I rely on you to do the exercise independently, and then you have problem, you still can find me. Okay? And if I think that's a very good technique that everyone should know, then um we will share it here. Yep. Uh-huh. I don't have this question now. If you want me to talk about it, you can, yeah, send me one. Yeah. And also I post the review. I'm not sure how many you see. I post the review question with solution in the Moodle as well. You also can try those. There's answer to it. Okay. Yeah, there's a lot of exercise you can try if you want. Okay. Don't be fed up. Okay. So last time we stop at the equation of plane. Okay. So if you look at this equation, right? Okay, my guess for some of the student, I mean some of the student that doesn't like maths is too many symbol. Okay, symbol doesn't make sense. Okay, for example, this plane here, a times x minus x0 plus b times y minus y0 plus c times z minus z0. Okay, so many symbol here. I think it's at least 10. So how does this make sense? How does this tell me there's a plane there? Right. Okay. How does this equation tell me there's a plane here? So how we derived this equation last time? ABC is really a, oh, okay. First of all, what information we need to build a plane? How many information we need? Two. Okay. One is a point on the plane. The other is the normal vector. So normal vector means 90-degree perpendicular to the plane, not vector on the plane, right? Okay. So ABC here correspond to the normal vector. Right? And then x naught, y naught, z naught correspond to the point on the plane. Yeah. So why there's a plus multiplication here? Right? Because we are considering the dot product between the normal vector and a vector on the plane. Okay. So every every point on the plane, okay, if you take the vector from that point to x naught, y naught, z naught, all these vectors should be perpendicular to your normal vector. Okay, so that you can extend everything you got a plane. Okay, make sense? So now you get you get this equation here. Okay. So after you know all these things, then you need to try to memorize or internalize this equation here. Okay. So A, B, C are fixed. So let me put. So these guys are fixed, some fixed number. This guy are fixed point as well. Okay. So the thing that's changing is X, Y, and B. So these are any point on the plane. Okay. Anything that satisfies this equation will be on the plane. Okay. Okay. All right. So let's try and do some example. So find an equation of the plane through the point 2, 4, minus 1 and perpendicular to M. Okay. So this question tells you exactly the information you need. Right or not? Yeah. Right. So it tells you a point on the plane and then a normal vector. So first you bring out the equation of plane first. Okay, so if you can't memorize formula, right, it's okay. You just take your formula out and then put at the side. Okay, so study the question side by side. Okay, so what is ABC in this case here? What's your ABC? 2, 3, 4. Okay, good. So we got 2, 3, 4. Okay, and X, Y, Z are any point on the plane. So what is S naught, Y naught, Z naught? Here. What's 2, 4, and -1? Okay, so these are the S naught, Y naught, Z naught, the point on the plane. Okay, ABC is a normal vector. So what do you get in the end? So you get 2x plus 3y plus 4z equals to 12. Okay, so you need to compute. All right, find the intercepts and sketch the plane. So find the intercept. So intercept what? So intercept here means intercept the x-axis, y-axis, and z-axis. So we got z-intercept. So during the class, right, some things I will assume you to know, okay? But let's say if you don't know, okay, let's say if you don't know, then you can ask me, then we will recall in the class. So for example, let's say I assume you know what is s-intercept here. So you say, sir, what is s-intercept? Okay, so then we will say s-intercept is when y equals 0, z equals 0. Okay, so if there's anything that I assume you know, but you think that you don't know, you can try and ask in the class. Okay, so when y equals 0, z equals 0, what do you get? You get 2x equals to 12, which is s equals to 6. Okay, so you get the point 6, 0, 0. Okay, so similarly, you can work out x-intercept and z-intercept. Okay, which uh, you get 3y equals to 12, and then for z equals to 12, which is y equals to 4, z equals to 3. Okay, so make sure you put at the right coordinate for this point. And let's sketch the plane. Okay, so you see why they find these 3 points. Remember the last lecture you tell me one way to find a plane. You said you need 3 points, right? Okay, so this is the 3 point they ask you to find. Because this is the 3 obvious point on the z-axis, easy to find. I mean on the axis. Okay, so we got these 3 points. We join this triangle. This triangle is not a plane yet, right? It's just a triangle. But if you extend this triangle, then you will get the whole plane. Okay, so that's why we just draw this triangle here. Make sense? Okay, next. So next, find an equation of the plane through 3 points. Okay, so they give you 3 points here, and then ask you to find the equation of plane. What's the information you need for a plane? A point and a normal vector. Okay, now you got 3 points. Okay, more than enough already. So you still need a normal vector. Okay. So how to get this normal vector here? Cross product. Okay. So for cross product, you need two vector. So how to get two vector out of these 3 points here? What vector you can use? Q, QR, and what? QP. Okay, let's try. So QR is where? QR is here. QP is, sorry, QP. Okay. Oh, QP is here. Okay. So QR, so use right hand grip, right? QR to QP and going up. I think it works. I think it works. Um, so what's QR and QP? Okay, I found out that QR and QP is uh, some of you, a lot of you use a lot of method, right? So you can use QO uh, plus OR, right? Or you also can use minus OQ plus OR. Okay, there are a few different ways to get equivalent way to get it. Up to you which one you want to use. Okay. Why we sometimes we prefer OQ and OR? Because OQ, OR, or something is just that point. Okay. You get what I mean? So every point, okay, is equivalent to the vector from the origin to that point. Okay. So okay, let me write it here. Every okay, let me write something down here. This one we mentioned before, but it's really important. It seems very trivial, but very important. So every point on Rn give. So let's stop at R3. So every point on R3 give a vector in R3. Okay. So in particular, so for example here, so Q is 3 minus 1, 6. It gives a vector OQ. Okay, OQ which is 3 minus 1, 6. Okay. So I was given a reminder by the other lecturer that we should stick to the notation in the notes. But if you use notation from previous, for example, linear algebra, it's fine as well. But we try to be consistent. Okay. So I use this row vector here. Okay. So here is a vector. Here is a point. Okay. Although they seems the same. Okay. But you need to differentiate whether it's a point or not, whether it's a vector. Okay. Is it clear? Yeah. Okay. All right. So maybe uh, should we should I let you continue yourself for this question here? Is it okay? Is it okay? Continue yourself. So you get these two vector. So first let's get these two vector here, and then the compute the normal vector. Okay, and then repeat what we do before. Yes. Okay. Any question with the plane here? I mean the plan the strategy we use. Okay. So for this question, again, like what I told you in the like what I told you told one of your classmates last time. So maybe you can do a lot of questions to help you to understand, but what we really look for in university is whether you know the skill or not. Okay, we can assemble the skill differently. So for this question here, what skill do you need to know? You need to know how to find vectors. Okay. Second, you need to know how to do cross product. Okay. Third is the most basic one, is how to put points and normal vector together to get a equation. Okay. So based on this skill, right, we can simply arrange the skill so that the question will look differently. So whether you can differentiate or not is whether you understand uh, every step or not. Okay. Don't just try to do, I mean, don't just try to practice questions. Okay. So see what question want you to do. Okay. Make sense? See every question what they want you to do. Okay. Otherwise, it's possible that you do 100,000 questions, you still don't know what's going on. Okay. So you need to understand what the question really want you to do. Okay. And then answer is for you to check whether you are accurate or not, whether you do it right. Okay. So method is really important here. Okay. So let's look at this question here. So the change question again. Okay. So find the point at which the line with parameter equation, okay, intersect the plane. So let's draw this picture up. So you got a plane. So in your mind, your plane should have a point and a normal vector, okay? Because you already got the equation. So you got a line that intersect here. So meaning, I don't know how these lines look like, maybe like this. And then you cut through, okay? They cut through at one point. Okay? So how to find this? How to find the point here? How to find? Any idea? So you need to make them equal. Okay, so what do I mean by make them equal? So the intersect, right? So this point is on the line, is also on the plane. Okay, so this XYZ satisfy both equations. Yeah, makes sense? So this point satisfy both equations. So meaning, so okay, let me write what I meant. Let x1, xy, xy, y1, z1 be the intersection. If it's very wrong, intersection. Okay. X. Okay, let x y1 y1 be the intersection. Then x1 y1 z1 satisfy x1 equals to 2 plus 3t, y1 equals to 4 plus t, sorry, minus 4t, z1 equals to 5 plus t, right? For some t, okay, for some t means at some time it is the point, and then also satisfy the plane equation for x1 plus 5 y1 plus 2z1 equals to 18. Right? Okay, so satisfy these two conditions here because it's on the line, also on the plane. Right? So what do you do? Okay, so you just substitute your y1, x1, y1, z1 from the line into the plane. Okay, see when it satisfies this equation. You get 2, 3t plus 5 minus 4t plus 2 times 5 plus t. Okay, so if you see this, right, I think you should feel happy here. Why? Because you got one variable with one equation. So meaning you can find that t. Okay. So you should feel happy here. Okay. So this is kind of miserable here, right? Because there's three variable, one t, And then here got 3 variable, 1 equation. Okay, but if you combine these 4 equations together, you reduce to 1 variable, 1 t. Okay, so meaning you can find the t here. So what's the t? Minus 2. Okay, so you get minus 10t equals to 20, which is t equals to minus 2. Okay, although it's a bit weird that the time is a minus, but so we haven't done yet, right? So t is the time, but we want the point. Okay, so we need to sub it back. Okay, so at t equals to minus 2, the intersection point is minus 4, 8, 3. Okay, so you need to sub it back to your line. Okay, if I need to make it complete, so just compute 2 plus 3 minus 2. Y1 equals to 5 plus minus 2. Z1 is equals to 5 plus, sorry, this one is Z. Y is minus 4 times minus 2. Okay. Okay. So far, okay. 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 Next. The next few I go relatively fast because I think there's some concept that you should see before. So angle between two planes. Okay. So if you have two planes, right? Usually you will take this angle here. Okay. Okay. So if you have a two plane, so for example, so let's say you got a two plane here, right? Okay. So you got two plane. What's the angle between the two plane? Is the angle between here, right? Okay. But this angle here, right, is really special. Not special. I mean, you can obtain it in a systematic way. Okay. Because plane can change, right? So one systematic way is you can use the angle between the normal vector. Okay, let's see how. Because the normal vector is 90 degree to the plane. Okay, so you can really just rotate the plane to the vector. Okay, or the other way, you can rotate the normal vector to the angle to the vector on your plane. Okay, so you can rotate it such a way that they are the same. Okay. Okay, so it's really the same angle. If you measure the angle between a normal vector and if you measure against the vector angle between the plane, it's really the same. Okay, so how to find angle between two vectors? So you see, reduce to the question. How to find angle between two vectors? You can take cross product or you can take the okay. So in this case, we take the dot product. Dot product is easier to calculate, right? So you just so in this case, we take the dot product. Okay. So this is really the dot product formula here. All right. So now you rely on your skill whether you can find the normal vector or not. Okay, given here. Okay. We do exercise. Exercise. Okay, let's do exercise. Okay, let's do this exercise here. So find angle between the two planes. Okay. So from this two plane, can you get two normal vector up? What's the two normal vector here? Can you quickly get the normal vector up? It is just the coefficient in front of the xy and z. Okay, it is the coefficient in front x, y, z. Does anyone disagree? Yeah. It's fine. So it's fine. It's fine or not? You're asking, right? Okay. Yeah, I think this is a good question. So it's fine or not? The answer is fine. It's okay. Okay, so why is it fine? So second question. Okay, so why is it fine? Right? So okay, so let's go back to what we derived just now. So we start with this. We start with this general equation, right? Equals to 0. So if we expand it, what do we get? Okay, and then we can move all the constant to the other side. Okay, but what happened is my A, B, C still remain the coefficient in front of my S, Y, Z. Okay, no matter how this part change. Okay, so why this part change here is why this become 5, why this become 1. Okay, so meaning what? So meaning if this is not 0, then this plane is not centered at okay. So if it is not 0, then this plane doesn't contain the origin. Doesn't pass through the origin. Okay, if it pass through the origin, here will be equal to 0. This part will be equal to 0. I mean, not this part, but this part here. Okay. If it is not 0, then it doesn't pass through the origin. Okay. Yeah. Yeah, good. So okay. Yeah. So how do you find the angle? So you just take the dot product between n1 and n2 and then compute the length. Okay. And then compute this number here, and then you find the theta. So I think the theta is cos inverse of 2 over square root over 2. Okay, so right. Yeah, is it okay? Can do the product, can compute length or not? Okay, so divide and then find the angle. By the way, if you go back, you do exercise, and then you check that, my answer is different from the lecturer's answer. You just straight away message me. Okay. Then we will figure out whether you are correct or not, or I'm wrong. Okay, yeah. And then if I'm wrong, I will make adjustment to the lecture notes. If it's a major problem, then I will bring it in front to the class, and then we'll talk about it. Okay. So next, I think this one is a bit harder. Okay. So try and think about this, how to find this. So find symmetric equation for the line of intersection L of these two planes. So you are given two plane equation. So you have to find the line of intersection. You need a line, right? So what do you need? You need a vector and a point. So how to find that vector? What's the relation between this vector and the two plane? Normal vector? Who was saying? Normal vector? Mm-hmm. Normal vector line on the two plane. Is that what you mean? Say again. Okay, so you're saying the two normal vector of the plane is perpendicular to the line of intersection, right? Okay, so does everyone else understand it? So do you agree or not? Ah, you don't understand. Okay, so he's saying that, okay, you got two plane, right? Okay, you got two plane. Okay, so if you take the normal vector of the two plane, okay, these two normal vector is perpendicular to the intersection line. Okay, so this is perpendicular in particular, and then okay, maybe I draw this a little bit differently. This maybe okay. So if this is normal to it, then this guy is also normal to okay, normal to this line as well. Understand or not? Understand the statement? So why is it true? Okay, so first thing you understand what people say first. Second, so why is it true? Why is it true? Why is it true? Yeah. The vector of this line is found both. All right. So this point, this line of intersection, right? Okay, is on both plane. Okay. So since this is a vector on that plane, right? So it should be perpendicular to the normal vector of that on plane. Right. In particular, it is perpendicular to both normal vector. All right. But the question is, okay, this is an important question. But it is not really clear that whether this information will help you find the equation of line or not. But it turns out that this question, it is enough. Okay. In real life, maybe you need more condition. Okay. This is just one condition you have. Okay. Maybe in real life, you need more condition. But it turns out that in this question here, this piece of information enough for you to find the equation of line. Okay, so let's try. Is it enough or not? Okay, so let's try whether it's enough to find the equation of the line. So you got n1. Okay, n1 is still 1, 1, 1. Okay, n2 is 1 minus 3. Okay, so uh how to find that line again? Okay, so just now we say that, okay, let's write out what we conclude just now. So L is perpendicular to both N1 and okay. So one way to find this is use the cross product again. Okay, so you want to perpendicular to two vector. Okay. So what do? You take cross product. Okay. So in this case, we will do it 1, 1, 1, 1 minus 1, 3. Okay. So do the test cross product. Okay. So work out. And then you will see that it's actually 5i minus 2j minus 3k. So this is the vector. Yeah, so this is the vector. So this is a vector. Let me see. It's a vector. So you need a vector and a plane. You need a point. Okay. You need a vector and a plane. I mean, you need a point. I think the claim is L intercept the origin. Hmm. Is it right? Oh, it's not right. Okay, so you need to find a intersection point. How is it quick? How can you quickly find a point on this line? Any suggestion how to find a point on this line? Let S to be 0. Okay, let S to be 0. And let S to be 0. So now we want to find a point on L. Okay, so let X equal to be 0. And then we will get what? We will get Y plus Z equals to 1 and minus Y plus 3Z equals to 1. Okay? Okay, so from here you got two equation, two variable. Can we solve this? Yes. Okay, so what do we get? We get, okay, let's do it step by step. Okay, I think from here is relatively easier because you can add these two together, right? So you get Z equals to 2 over 5. Okay, and then you found that Y will be equals to, what's this? So 1 minus 2 times 2 over 5 over 2, which is 1 over 10. Z is 3 over 5. No, I add these two together, right? Oh, sorry, here should be 2, sorry. That's right. So let me change this. So this is 2, so this is 3, and then this is 3, and then this is minus. Okay? Okay? Okay, so you got a point here. So we got a point. So find P. P is equal to 0, minus 10, and 3 over 5. Okay? And then we got the vector here. So our L is equals to B times T plus P, which is 5, no, equals to 2 over 5. Or you mean 3 over 5? What are you trying to say? 2 over 5? 6. Wait. What's going on? 1 minus 6 over 5, right? Isn't it this? Oh, wait. Okay, correct. Wait, let me see. 1 minus 3 Z minus T. Okay, correct. Okay. Yeah, okay, good. Okay, good. Over 5. Okay. Yeah. Okay. Okay, good. So what's next? So we got this. Yeah. So we got VT plus 0, 2 over 5, 3 over 5. Okay. Okay, so we got this line equation here. So how to get symmetric equation? How to get symmetric equation? Okay. So if we have this L as x, y, z, okay, equal to the right hand side would be and okay. So how to get XYZ? X is equals to 5t, y is equal to minus 2t plus 2 over 5, z is equals to minus 3t plus 3 over 5. Okay, so this is the parametric equation, right? So if you want to turn it to symmetric equation, what do we get? Let me make some space. So what do we get? We get 3 over 5 equals to y minus 2 over 5 over minus 2 equals to z minus 3 over 5 over minus 3. Okay, so these are few equivalents way to write the line. So depend on what question needs. So if the question needs the parametric equation, then you stop here. If it needs symmetric, so let me write down. So this is the parametric equation, and then this is the symmetric equation. Okay. Okay, maybe we take a break until 9. Take a 10-minute break. Smaller, okay. Ask a question. No question. Okay, wait. Hey, can you send me just now the question you helped me just now? I scared I forget. And then I will make the changes. Okay. Yeah. What question you want to ask?
因为我们这个已经求破这个那个分开那个对吧？然后就是任取一个点嘛，任取一个平面上的点。但是就是同样的公式，你代入不同的点，怎么会是一样的呢？就是怎么会是一样的？
sorry，
我就是突然想到这个事。
对，你可以试下。
好。
然后至于为什么啊，你给我想一下。至于为什么哈？因为啊，我可以告诉你一个问题告诉你一个东西，就是假设我不知道你听不听得懂的是，我告诉你。
好，你说吧，你说吧。
你看，不管你 OK， 你看最后的这个结果不是？
对。
看这个最后的结果啊，这一个是每一个点都要符合的不？OK， 所以不管你选哪一个点在这个 plan 上面，它一定要最后算出来是这个。
对啊。
对不对？所以不管你换什么 x0、y0、z0，它的组合不是到最后都是一样的方式。呀，
我想的问题就是说，如果你选择不同的点的话，
对，
它最后算出来的这个形式的这个
形式会不一样，但是如果你简化过后，一定是一样。
可是前面的省都是一样的呀。
对啊，可以选对。
对，所以它只有 cos 不一样。
所以它加减过后，哎，又出来这个加减过后，哎，又是出来这个。
哦，好，那我回去试一下吧。
你
是说
试一下啊。
最后出来的是什么？最后出来的是就是同样的 constant 的 coefficient。
一定要一样，不然的话就不在这个 plan 上面。
好，我回去试一下吧。
你可以试。
好的，还有个问题，你先问吧，学长。
就是你之前写的那个黑板上，就是对，哪个是你的这个？就是
我的啊。
对，等一下吧，
OK。
我没什么，你先问。
就是你那个黑板上，就是你前面写的，就是我想问，
前面
对，前面
在前面，
对，在前面，就是很早之前面，对，差不多是
这个已经是第一个。
后面，就是你就是这两个平面要说明什么？
那我可以这样说明什么？OK。之前我说嘛，这个圆圈嘛，对不对？这个圆圈 只需要0到2拍的这条直线来绕一圈嘛，对不对？OK，所以相等的，你如果考虑不同的形状的圆圈的话，OK，我也只需要到这一节的线就可以了，对不对？因为 R 如果短的话，就是代表里面的圆圈嘛，R 如果长就代表外面圆圈，所以我只需要蓝色这个部分的线，来 cover 我整个 XY plane，OK，所以说那发生什么事情呢？对于外面的这些点发生了什么事情？
循环就差不多。
循环就是说我们把拍和拍加滴答和滴答加拍的点，我们把它英文是说 identify 起来，
这什么意思啊？identify 的中文是什么意思？
就是
认
为它是相同的，
对，认为它是相同的。我不知道中文这样，就是把它 identify 起来，连 minus r 跟都可以 identify 上去。
然后后面还有个就是
那个，
在后面
很多，
多后面
人物很多，
就是应该就是那个，应该我后面想问就是那个西塔跟西塔加2拍，就是你认为在几坐标系你认为相同是吗？
在哪个坐标系线？
就是那个polar，
哦，对，在 polar coordinate，对，是一样的，对，哎，对，谢谢。我觉得你刚才的问题可以在课堂上问出，因为我觉得他们有嘛。对呀，如果你问的话，大家就会在。
我们主要的不是很阿根，
没有，这两个是不同的。就是这个我也有做这个 identification，这个要做一个相对的 identification，两个。然后继续。
那你加个传下去，它就会
他会怎样？
对，
它会 exceed 咯，对咯，它会 exceed 咯，所以我要让它，对，要怎么讲呢？比如说我有一个拍嘛，有一个拍对不对？但是假设我出到 3 拍啊，OK，这里是3拍嘛，对不对？所以其实它和1拍是一样的。对，你们知道在做这件，I mean，你们知道有来我们在 Polar Coordinate 有这件事情发生，就转一圈过后是一样啊，对，
我做那个，
听不懂啊，睡觉，还是听不懂，哎，
这个是从0到完成来，就是我画的是画的是这样子的，一个0，我找了那个0吧。我看答案之后，它其实是来自己绕2圈。这里是到2排，这是到3排，这是到3排，这是到4排。
对，所以你要表达什么现在？
那我想问来，
怎么 graph 这个 graph？哎，我要看一下。你发给我一下，我要看一下，我还没有看过。你是说要看它怎么样 intersect 还是你是看要几个圈，还是？
对，我也是来，怎么着？
你先给我看。可以。OK。
我是在听的。
Hey, how about you?
Yeah, I just want to ask about the play.
Yep, sure. Sure.
So this is the formula.
Sure.
Can you explain more about the main idea behind this?
The idea is you take the dot product with the vector on the plane. Okay, how to get the vector on the plane is you take this point here, or actually take this point minus this point.
And then this point can be anything.
Anything on the plane.
Yeah.
So XYZ is anything on the plane. So you take this point here minus the point here, then you will get a vector on this plane. And then this vector, you need to make sure it is 90 degree to the normal vector, so that you will get the plane. If it is not 90 degree, it's not on the plane. Only when it is 90 degree, so equals 0, the top product equals 0, it is on the plane. So that's why equals 0 here. But if you see there's like non-zero, for example, just now we have a non-zero here, right? You see, we have non-zero here, right? Because it is because it's came up from this point here. It came up from this point. So the point, it means that what it means is origin is not on this plane. If this is not 0. So I mean, you see, this non-zero part here is came from this constant part. You see, if I expand this equation now, okay, I can collect this constant part here. Okay, also the
coefficient still in the
sorry, say again.
the coefficient A, B, and C
Is what?
is still in the
It still remain the coefficient of x, y, z. Okay, just that I combine the constant term. Okay, I combine the constant term. So this constant can be 0 or non-zero. If it is 0, then that means it passes through origin. If not, then origin doesn't pass through. Because you see, if you substitute x, y, z equals 0, 0 not equal to 5. So 0 is not, doesn't say. So this is coming from dot product. Yeah, because you want the 90 degrees. So dot product is 0, 90 degrees. Yeah.
If this survives, so it can be
What do you mean?
90 degrees.
No. You cannot see like that because this is after simplification. Before simplification is this one. So you need to look at this original form. Yeah. This non-zero doesn't tell you what perpendicular or not because it can be non-zero due to this constant. Okay. It can be non-zero. I mean, you see, these two looks really different, right? These two.
Yeah.
Because this one contain x minus something, but here is x minus 0. So I mean, you cannot really say much with this yet. If you see this, then you can tell everything. You can tell whether what point is on that plane and then what normal vector. Only when it is equal to 0. If it is equal to something else, you cannot say anything. Yeah, try think about it.
We think.
Yeah, you think about it. So this equal 0 is the crucial part. Not equal 0 doesn't tell you anything. Equal 0, then you will know more. Not equal 0, you don't know what's going on.
This what is inside the
equation. Yeah, it's not equal 0, you cannot tell much. You only can tell from the coefficient of x, y, z, the normal vector.
Thank you.
Yeah.
刚刚那个两个 plane intercept 哦，
对，
那个 L 啊，它的 concept 是 based on 这个，就是如果我的 L perpendicular to both N1 跟 N2 嘛，
对，
那它就是这样子，你 N1 cross product N2，
对，
那个 concept
就是那个 concept。
哦，对，
就是那个 concept。对，没有错。他说如果一条线 perpendicular to 两条线的话，是不是就是 cross product 啊？
对哦，就跟那个为什么不能直接连那两个平面呢？
那个两 OK，你说 equal 它那么 equal 对不对？
不就对 equal 对 equal
啊，可以，可能好像很复杂。
你解出来不是？但是
你就一个 equation，你就一个 equation，可是你要解两个 variable。
3个。
OK，其实是可以，可以。我给我想想，
因为是3个 x y z 嘛，3个 variable，然后是2个方程。
对，
解出来后是有一个变量的，就是比如说你 x y z
2个变量，一个方，一个等，一个。
解出来应该是
可以试下，可以试下。
不是我想了过，我解出来的时候是好像是 y 等于2/3。
快点。
好 ，y 等于2/3 z， 然后 x 等于多少 z 加上多少，然后就这样子。你懂我意思吗？
我懂，你写出来一次
啊？
你写出来，等下给我看。OK 啊？可以，等下发给我。OK， 包括你错的或者，包括你错的。 Quick question. Okay. Right. So yeah. Okay. So let's start. Some of you still in toilet. Okay, maybe one more quick question. Still got question from the back just now. 你后面没有？哎，大来。Okay, any question? I mean, I think you have a lot of questions, but you don't want to ask. So many people asking you. So I mean, sure. Do you have some quick question now? I can settle it before we start new stuff. Don't think so. Any quick question or not? Any quick questions? Question. Okay, I think one again yeah, okay, anyway, I will say it. So if you have a plane equation, right? Okay, if you have a plane equation. So whether this is non-zero, okay, you doesn't know anything from this equation here. The only thing you know is the coefficient in front x, y, z. That is the normal vector. But you don't know what point is on the plane. Only when this part is zero, okay, the constant part is zero, you can read out the point on the plane. Make sense? Okay, so if this plane equation here, it is non-zero constant, you don't know anything. Okay, only when the plane equation is zero, you can read off the s naught, y naught, and z naught from the equation. Okay, that's what I want to tell. If you don't understand what I say, think about it. Okay, think about it, and then if you still don't know, to your friend who know it. If your friend, okay, so help your friend. If you guys still cannot figure out, so come and find me. Yeah. Yes. There's no way to find her. Yes. Let me think. I don't know. But there's one simple case. Okay, one simple case I know what to do. So let's say, okay, there's some. Okay, this answer I addressed to him, so you guys can try to understand what I want to say. So let's say, okay, let's put in this way. Okay, ax. Okay, this is a bit advanced, but anyway, if you want me to tell the story, so let's say this d, right? So this d is not equal to 0. Yeah, not equal to 0. We don't know what point on the plan unless we go and solve it. Try and error. Okay. Let's say this d, right? If d is a linear combination of ABC, then we should be able to solve it. You get me? So let's say d is equal to, let me put what? Maybe we put sigma A plus delta B plus theta C. Again, let's say we have this combination. Then we can move my D to the other side. And then I do factorization. Right? So now we can find the point. Right? If we can able to make it back to this form, then we can find the point. S naught, Y naught, Z naught. Okay. So this is an easy case. If I have a linear combination of these coefficient, then I can just move it across and then I spread it and then I do factorization. Okay, this is easy case, but for the other case, not sure. Okay, at least not on top of my head. Then don't do it. I mean, depend on what you want to do. Yeah, depend on what you want to do. Okay. Okay, another question from the front is, if this constant is 0, okay, can we assure that origin is in the plane, right? Okay, so if it is in this form, you cannot. If it is on this form, you can. Okay, unless you already move all the constant across. Okay, then you can. Okay, then you can. So let's say ax plus by plus cz equals 0. Okay, then this implies that origin is in the plane. Okay, why? You just put xyz equals 0. Okay, 0 equals 0. 0 satisfies that equation. So 0 is on the plane. Okay, but in this case, it's not. Okay, so in the general case, it's not. Because if you put this as 0, this as 0, this as 0, if the constant doesn't add up to 0, then you will be in trouble. Okay. So far, okay. Okay, let's move on. Yeah, these are quite good questions, so keep going on. The rest, please follow up. Okay, if you can't follow, that's fine. It's okay that you fall back, but please don't stop working. Okay, please don't stop advancing. Okay, please don't stop. So next is a distance from a point to a plane. Okay, so you have a point, you have a plane. I think this one is quite. I think you should remember from linear algebra. You got one point outside. Okay, okay. You got one point outside the plane, so you need to project it back and then find the what? I think we call it a least square length. I think that's the thing we call it in linear algebra. So you got a plane. Okay, you want to find some point outside the plane to the plane. Okay, so what's the distance from a point on the plane to the plane? A point on the plane to the plane. A point on the plane. Okay, so you got a plane, you got a point on the plane. So what's the distance? Wait. No, not so advanced. So what's the distance of a point on the plane to the plane? So you got a plane, right? So you got a point on the plane. Okay, so imagine any point inside the plane. So what's the distance of that point to that plane? 0? Yeah, 0, because you're already on the plane, right? So it's 0. Okay, let me pass down this again. Okay. So the problem is, if the point is not on the plane, it is positive length. Okay, so how to find that length? So it's given by this look horrible. Okay. So what's this? So it's a. So you have your point x1, y1, z1. Okay, and then you have this plane here. Okay. So what you do in this formula is you just sub this point here into your plane formula here, plane equation, divided by the length of normal vector. Okay. So why is it so? Okay. So why is it so? Actually, this is coming from the scale, the projection to the plane. Okay. So you are computing the. Okay, just now Hong-Ming talked about Gram-Schmidt, right? Okay, so what's the idea behind Gram-Schmidt? So Gram-Schmidt is you project the vector into the subspace. Okay, similar to this question, you project the vector into the subspace. So you project B, is it? I call it what? Here is what? The N. Yeah, let me see. Let me see why I call it B. What's B again? Okay, B is this guy here. Okay. So this is what you want. Okay. So you project your B into your subspace. And then you compute the vertical length, or you just project it on the N. Okay. So you can project your B onto N. Okay. So it's like spread into this horizontal component and the vertical component. Okay. So if you project to N, it is the vertical component. If you project to horizontal component, you still need to take difference. So you just project to the vertical component. So you project to the vertical component. So you take product with B and N. Okay. Okay. So this is how you get this equation here. Okay. Otherwise, you just memorize this formula here. So this formula here is just substitute the point into your plane equation, and then divide by the length of the normal vector. So let me put it here. So this is the length of normal vector. Okay. So also note that, also not one thing. There's one thing to note here. So you can see that if you sub it back to the plane equation, right? If this is 0, then that means it's on the plane. If it's not 0, it's not on the plane. Okay, so that's why this quantity here makes sense. Okay, this should be something non-zero because it's not on the plane, right? Okay, so in particular, it doesn't satisfy this equation here. Okay, so you should get something non-zero here, and then you divide by the length of the normal vector. So why you are dividing the normal vector here? Because of the projection you learned before. You need to take consideration of the length of the vector. Okay. Yeah. If you are interested, you can try and write this out, but we won't do it here. Okay, yeah, sure. Okay, yeah, sure, correct. Okay. What should we do? Okay. Keep going. So okay, let's try one example. Okay, let's try an example. So find distance between the two parallel planes and x to y to z and 5x plus. Okay, so one difficulty of this class is, I guess, one is concept, second is mesh this concept together. Okay, for example, this question here, find distance between two parallel planes. I give you two planes, they are parallel. So I say I want to find distance, but what I teach in the class just now is I only tell you, given a plane and a point, you can find the distance, correct? So now it's two planes. What to do? Where to get the point? Huh? So you need to find a point first. Okay. So what point you want to find? Any of them. So we pick one of them. So let's pick one of the plane and then we fix one as a plane, find point from the other. Okay, so let's call it P1 Okay, let's call it P1, P2. Okay, so you want to find point from P1 or P2? P1, okay. So let's find one point from P1. How to get a point out of P1? There's so many points here. What point you want to keep? Sub x equal to 0. Okay, sure. We sub x equal to 0 first, and then we get 2y, 2z equals 5. So when you set x equal to 0, you still get one whole line. So I need a point. So how? Set y equals 0 again. Okay, set y equals 0 again. So y equals 0, we'll get minus 2z equals to 5. So which is z equals to minus 5 over 2. Okay, so now we get that our point is 0, 0, and minus 5 over 2. Okay, so now we got a point, we got a plane. So now this setting is the setting that we have just now. So we can use the formula. Oh, what's the formula? So let's take our formula. So if you cannot remember, just bring your formula beside you. That is another question. So try to memorize first. This is what I'm told. Okay, I'm being told. Yeah, I mean step by step, right? Step by step. I cannot straight away ask you to fly. Right. So work first. After you can work, then try and fly. Just kidding. Okay. Okay, so let's come back. Yeah, I mean human try to fly, I mean, ever since ancient time. So we make an airplane. So we make an airplane is actually a one big advancement in human history. And then Elon Musk is going to make spaceship, right? Okay, so yeah. Okay, anyway, so let's keep going. So so okay, let's come back. So so what's our plan? Our plan is P2. So P2 is 5x plus y minus z equals to 1. Okay, so we got a point, we got a plan, good. This is everything we need, right? So we just substitute it in the formula. So A is what? A is 5 times 0 plus 1 times 0 plus minus 1 times minus 5 over 2 plus 1 over square root. A is what? 5 squared plus 1 squared plus minus 1 squared. Check. Okay. Where should be minus 1? Yeah, try check. D equals to minus 1. C, correct. Good. D equals to minus 1. So, okay, so let me be very sure. So we have to move it into this form here. Okay. And then the form that we want is ax plus by minus, sorry, plus cz. Okay, plus cz plus d equal to 0. Okay, so that's why we got d equals to minus 1. So what's this whole thing here? Is it square root 3 over 6 or not? 3 over 6? Check. Is it root 3 over 6? Yes, okay. Okay, any question for this? Any problem for this question here? Do we do one more question on this, or you can move on? You want to move on? One more. Okay, one more. Okay, one more. I think this one is more interesting. a little bit more. Okay, let's try one more. So find the distance between two skew lines. Okay, so what's skew line? Can someone recall what skew line is? Don't intersect and then not parallel. Okay, good, very good. Not intersect, not parallel. So we got these two lines here. Okay, so non-intersect, non-parallel. So what is going on with non-intersect and non-parallel? So as last time we say, there can be non-parallel, meaning the vector might not be scalar multiple of each other. They still don't intersect. Okay, so maybe they go like this. Okay, yeah. Okay, but they lie on a parallel planes. Right? Okay, so if you have two skew line, right? Okay, if you somehow extend this line, actually they slip on two parallel plane. Make sense? Make sense or not? Okay, yeah. You can find two parallel planes that they sit on. Okay. Okay, if I already tell you this, then this question can go resolve to the previous question. Right? Okay. So now the problem is how to find the plane. Okay, how to find the plane? How to find the plane? Okay, so you got two vector. Okay, you want to find the normal vector for the parallel plane. So how to find? Cross product again. Okay, so you take the two cross product and then you get the normal plane. So let me draw something out. So you got this plane here, and then you got these two plane here. Okay, so these two should have the same normal vector. Okay, or scalar multiple of each other. So they should have the scalar multiple of each other. So maybe I call it n, and then maybe this one is a cn. Okay, they're not necessarily the same, but scalar multiple of each other is okay. Linearly independent. Okay, so what should we do? So we need to take cross product. So we need to take cross product of who? Okay, so L1. What's the direction of L1? 1, 3, and -1. Okay, let me write down. So V1 is equals to 1, 3, and -1. Okay. So how do you get 1, 3, and -1? You just get the coefficient of your T. Okay. L2 is equal to V2 is 1, 1, and 4. Okay. 4, right? 2, 1, 4. Right. Okay. Okay. So yeah. So I mean, really you should remind yourself the solution to the homogeneous equation here. You should remind yourself this one. So this part here is really a line. Okay, the direction of the line. And then the line is made up by the t. If you vary the t. Okay. So now what's our strategy just now? So we take this two vector and then get our cross product and get our normal vector. Okay, so let's cross it. What do you have? Does everyone get this answer? 13i minus 6j minus 5k. You can if you don't write it down, you can quickly do the computation that you have. So 12 plus 1, and then 5, 4 plus 2 minus because of the plus minus plus sign, and then 1 minus 6, which is minus 5, and then plus on this side, so I think minus 5. Okay, so far okay. Okay, so you got this normal vector here. All right. What else we need to get? We need a plane. We also need a point. Okay, so what point do we want? So what point you want to get? You want to get point from L1 or you want to get point from L2? Whatever. Yeah, choose one. L2. Okay, let's pick L2. So what point you want to consider? When? The easiest one is we will set something to 0. So we'll set x to 0. So we will get so what we get is 0, 3, and minus 3. Okay, so we got this on L2. Okay, I think we haven't quite get the equation on L1, right? So I think we still need another point. We still need another point. Okay, so first of all, you want to make L2 into a plane or L1 into a plane? L2 into a plane. So let's find the plane equation first. So let's find. Okay, let's change this point here. W1, W2. Let's find a plane P2, okay, containing L1, L2, okay, containing L2. So it is, I already found the ABC, which is 13 minus 6 minus 5. So we need to find the S0, Y0, and Z0, which is, okay, let's keep this S0, Y0, Z0 so that you know what's happening. So which is X minus 0, Y minus 3, Z plus 3 equal to 0. Okay, so this is our plane. So if you want to make it into the ABCD form, it is 36 minus 6y minus 5z plus 3. Okay. Hey, what time we finish class? 11, right? So why someone standing outside now? Awesome. You want to come? Not sure why she's here so early. Okay. Vertical. Okay, so we got a plane. We still need a point. Okay, so find another point. So we need a point from L1. Okay. So from L1, get the easiest one. Okay, don't do hard things. Do easiest one. So take t equals 0. So we'll get a point, which is what? If I set t equals 0, I get 1 minus 2 and 4. Okay. Okay. Good. So up to here, we can use the formula again. by1 plus c z1 plus d over square root of the, this is the length of your normal vector. Okay, so you sub everything in, and then you should get 8 over square root 230. Okay. Anyone have question on how to sub these two value here. So let me bring out the necessary information here. So we got, let me move it here. Yeah, actually, what we have is these two. Okay, so sub these two set of number into this equation. Okay. Okay, it's okay. 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 Do we continue? Continue. Okay. Let's continue. Yeah. Okay. Continue, or you guys still want to calculate first? Huh? No, not yet finished. I haven't finished yet. Still got 1 hour. Okay. Okay, next. So we're gonna start. I haven't started yet. Okay, so I keep going. Okay, so this is the part I talked about. We want to do a 3D version of parabola, hyperbola, and then what else? Eclipse. Okay, so we are doing the 3D version now. So in 3-dimensional, okay, if you have a graph that relate x, y, two of them, either x, y, x, z, or y, z, okay, to a constant, they are all cylinder. Okay, they are all these shape are cylinder. Okay, so for example, okay, if you doubt about this definition, right? So just take the easiest one. S squared plus y squared equals to 1. Okay, this is a very classic example you need to remember. So S squared plus y squared equals to 1. What do you get in R2? Yeah, in R2, two-dimensional space, you get a circle. Okay, so if you consider this in R3, okay, in R3, 3-dimensional now, you have a z variable. So there's no condition on z. So you need to take all the circle at every z. Huh? What? Yeah. So if you take circle at every z on the z-axis, what do you get? A cylinder. Okay. So this is the very first example you see. So this is a cylinder. Okay, infinite cylinder on both ends. Okay, doesn't end. Up to down. Okay. So the next is how to sketch the graph of the surface z equal to x squared. Suppose I haven't shown you yet. Okay. So can you imagine what does this look like? Shell. What's the shell is? Can anyone imagine what this looks like? Right, this is still there. Okay. Anyone? No? What's the shape? Paper roll? Paper roll. Okay. So you know what is y equal to x squared, right? Okay, so it's just like that. But this one changed to z. So meaning just change to the z axis. Okay. And then you still got one more variable, a y. Okay, remember we are living in R3 now, 3-dimensional space. So y, we don't care. So meaning for every y, we have this thing. Okay. So meaning we got something like this. Okay, and then keep going on. No end. Okay. Infinite limit. Okay. So what do we have? So we have this thing. Okay. So start imaging from z equal to s squared here. Okay, and then you extend. Okay. Okay, let's continue. So testing your imagination. So I think that we talked about this, right? S squared plus y squared equal to 1. Okay. So we talk about this. This is the infinite cylinder. So you start with s squared plus y squared to 1. And then in every dimension, in every point in the third dimension, you have this circle here. Okay. Okay. So we'll keep going. What does this mean? Identify the surface. Okay, let's draw this out. See what do you get. This seems a bit similar to what we have just now. So what's the difference? Okay, let's suppose we fix our axis. So our axis usually is go counterclockwise. So it's x, y, z. Okay. So how does this cylinder looks like? It's circulate around x-axis. Okay. So in that case, it's something like this. Because this is for any x. Okay. So just now we have a vertical cylinder. Now we got a horizontal cylinder. So in particular, if you want to do the other side, then you will have z squared plus x squared equals to 1. Okay. So depend on what variable you want. Okay, next. Next is this quadric surfaces. So like what I said last time, we want to classify all the quadratic equation. But now you got 3 dimension now. You got x, y, z. Last time we only have x, y. Okay, now we got x, y, z. Okay, so the general form is this, all the cross term you will have. Okay, all the 2-dimensional degree you will have. Okay, so you can see that this is a two degree of 2 polynomial. Okay, and then this is degree 1, and then degree 0 constant. Okay, so let me write down. So this one degree 2, and then this one degree 1, and then this one degree 0. Okay, so degree 0 is a constant. Okay, so how to classify in this case? Okay, we also have classification in 3D cases. Okay, let's see what do we have. So it says that if you play around with this equation, either translate it or rotate your coordinate, actually you can reduce to these 2 forms. Okay, so these 2 forms, we just need to care about these 2 forms. Either all of them is in x squared, y squared, z squared, or x squared, y squared, and z. Okay, these 2 forms. Okay, so from these 2 forms, we classify the surfaces. Okay, let's see what do we have. Okay, so we have, let's show us. So we have all together 6 of them. Okay, so we look at it one by one. Okay, when we look at this one by one, right, it's important to see the cross section of this shape. Cross section of this shape, because the question will involve giving you cross section, and then you try and figure out what is it, or give you the shape and then figure out the cross section. Okay. Okay. So first is this ellipsoid. Okay, so you can see that this part here, right, is really similar to ellipse. Okay, ellipse. If you get rid of the third variable here. Okay, and then if you fix any z, it is fix any x, y, z. It's really just ellipse. Okay, ellipse. And second, we have this elliptic paraboloid. Okay, so if you fix z, right? Okay, if you fix z, it is just an ellipse. Okay, so if you fix z, it is an ellipse. Okay, so y doesn't grow to below. Why? Yeah, because here are all square of number, so it's only positive on the right hand side. Okay, so you only can get positive z. Okay, so that's why you only got half of it. Yeah, so if you fix the other variable, then you will get parabola. Okay, parabola. If you fix fix x or fix y, then you will get parabola, right? Okay, so for example, if you fix this, okay, so this is a parabola. And then next is a hyperbolic paraboloid. Okay, so this one I think is harder, a bit harder to see, but you can see that this, if you don't look at this z over c, right, this part here should remind you of the parabola. Okay, so you have parabola inside this curve here. Okay, then we also can get con. Okay, just from last time we cannot get con, right? Last time we only get sections of con. Okay, now we can get the whole con if you have z squared, x squared, and y squared. Okay, so just now we have s squared y squared with z, s squared y squared with z, and then this one is s squared y squared z squared, and then this one is when this one is gone. Okay, when this one is gone, and then we have this equation here. Then we'll get this on here. You can see that the horizontal part is all ellipse again. Okay, because if you fix this part to constant, you get ellipse equation. Okay, and similarly, if you fix x or y, then you will get this hyperbola. Yeah. Okay. So next is hyperboloid again. Hyperbola of one sheet. So you can see that this here, the difference here is the center here is not just a point. Okay. So the center here is non-empty. Okay. This is very important here because this is a singularity point here. If you can open up this singularity, maybe you can pass through. You can pass through. Huh? Okay. So you can see that the difference between hyperboloid and ellipsoid is just different in the sign, right? Different in the sign. Okay. Differ in the sign, then this shape become an infinite shape. This shape is a finite shape. This shape close up, the other shape open up. And the next one is a hyperbola of the two sheets. So if you have more negative, right, then you will find that this singularity actually break up. Okay, break up. Yeah. Okay. Nothing much to say for the moment. Let's try and learn how to sketch this guy. I'm not sure actually. Seems is thought, then I think will come up. Okay. What? Huh? 3D shape. I mean, just simple one, not the. I mean, let's try. Okay, let's try. Okay, let's try. Yeah, how to sketch? Okay, so how to sketch? Okay, how to sketch? So, okay. So first of all, this is what this formula is. Okay. So this is x squared y squared z squared first of all. Okay. And then the sign is all positive, and then equals to 1. Okay. So this means this is the. So you can see from here, there are 4 of them involving z squared, x squared, y squared. Okay. And then it is all positive and equal to 1 is only ellipsoid. Okay. There are 3 of them equal to 1, but only 1 of them are all positive. So should be something like this. Okay. Let's say you don't remember all these things. Okay. You don't remember these 6 picture here. Never mind. We can do from scratch. Okay. We can do from scratch. So how to do from scratch? Okay. So we can fix fix axis first. Okay, let's say we fix Z. Okay, let's say we fix Z. We slash a plane at Z. Okay, and see what's the shape is it. Okay, so we slash a plane at Z and then see what is it. Okay, so this is what I need you to know from last time. Okay, which is you learned before. Which is what you learned before. Okay, so it is this one. Okay, so what's going on here? Okay, so what's going on here is from last time, you know the x squared y squared over 9 have to be equal to what? Some constant. 1 doesn't matter, right? Doesn't matter. Doesn't matter equal to 1 or not from last time. Anyone can recall from last time? Close to 1. You sure? Okay, wait, let me write something down first. So this will give a condition on K. Okay. How to give condition on K? What's the ellipse equation from last time? Anyone can check. What's the ellipse equation? S squared over A squared plus Y squared equal to 1. Okay, okay, good. Equals to 1. So this thing is 1. Yeah. I mean, do you mean why do I want to move? You may make this one equal to 1. Why you want to divide? Oh, okay. You mean, oh, I get what you mean. So you mean, okay, you mean this, right? Yeah. Equal to 1. Okay, yeah, makes sense. Okay, so so what's next? So what's next is this thing have to be greater than 0. Yeah. So actually 1 minus 2k plus 4 have to be greater than 0. Right? Because a square is always 0. Yes. Okay, so this thing have to be always greater than 0. So this is a trick here. This is a trick here. So you need to know that this part here is greater than 0 because you have a square and b square. Right? So this part has to be 0, greater than 0. So what do you get? I think to solve this guy, right? Okay, so this one have to go back to what you have learned. So it's if you factorize this, what do you get? 2 plus k and 2 minus k greater than 0. Okay, so how to solve this? I think you need to draw something like this, right? Drawing the right picture, and then minus 2 and 2. Okay, so something greater than 0 is inside here. Does everyone recall this method? Recall this method? Okay, yeah, okay. So your k have to live between minus 2 and 2. Okay, good. So the idea here is you need to memorize. Okay, I don't think you guys like memorize. So the idea here is you need to know what's the basic equation. Okay, haven't memorized yet? Never mind. Just bring the formula sheet beside you when you do the exercise. Memorize first. This is what the other lecturers say. Okay. Okay. So fix as z Okay, we know that it's an ellipse. Okay, so how about fix a k? Fix an x. Okay, fix an x. We also get similar stuff. Okay, let's quickly go into it. So we also get similar stuff, which is this. Okay, and then you also do similar trick. So divide by 1 minus k squared, and then make sure that this thing is greater than 0. Okay, so make sure that 1 minus k squared greater than 0. Similarly, okay, and then you will get what? You get ellipse again. You get ellipse. So let me ellipses from -1 to 1. Okay, and then you also do the same for y equals to k, and then you get ellipse again. Yeah, so you still get ellipse. So 4 equals to 1 minus x squared over 9, and then if you do similar trick again, then you get -3 to 3. Okay. Okay. So this 3k, right, give you the range of x, y, and z. Okay. So your range is starting from your intercept. In particular, you intercept 0, 0, 2 at z, and the other side is 0, 0, -2. And then for y, you will get 0, 3, 0, and the other side is 0, -3, 0. And then for x, you have 1, 0, 0, and -1, 0, 0. Okay, and then all of them you have ellipse, and then ellipse, and then the other side ellipse. Okay, so all together you get this like a rugby ball. Is it rugby? Yeah. Okay. Okay. I mean, first time seeing it is quite horrendous. So if you do more, maybe you'll get used to it. Okay. Yeah. You can try the same method. Try same method on this question here. Then we will discuss other cases. So try same method here. Okay, try same method here. Okay, let's go on. So one harder one is this one. Okay. How to sketch this surface here? Sorry. So it's a y squared, z equals to y squared minus x squared. So you will see that if I snooze z, okay, I've made z into constant, then this is what? I think hyperbola, right? Hyperbola, what's the equation? Let's write down. Y squared over s squared minus x squared over b squared equals to 1. Okay? So if I snooze z, I'll get some hyperbola. Okay? If I snooze either y or either z, I will get parabola, right? So we'll get something z equals to y squared or z equals to minus x squared. Okay? So so in z you will get hyperbola. Okay, so open up. In y or x direction, you get parabola. So how you imagine this picture here? Okay, let's imagine this picture here. So, for example, if we snooze the z, okay, make it a constant, we will get all the hyperbola. Z, y, similarly, we get hyperbola, but on the other side, because it's minus. Okay. And then how about z? Okay, in z, we get hyperbola. Okay. Hey, that part start playing game already. Huh? Okay. So we get hyperbola in the z direction. Okay. So what's next? So next we need to combine these two pictures together, these three pictures together. Okay. So on the X direction, you have this growing. Okay. And then on the Z direction, you have this shape here. And then on the Z direction, this hyperbola change whether you are positive or negative. Okay, change the direction. So you need to combine this factor together, and then you will get the whole hyperbolic parabola. Okay. So you can see in Z direction, you have this hyperbola growing. Okay. And then in which direction? In the Y direction, you have this growing. Okay. If you slash the Z direction, you will have this hyperbola growing. Okay, so hey, there's an interesting way to think about this picture here. Okay, this is an interesting picture here. Okay, this is related to what I researched on. So how to think of this, right? So you can think of these two hyperbola here. Okay, it's exactly this Z here. Okay, you start from this and this. Okay, so you need to imagine a surface that connect these two 2D picture. Okay, so you need to connect these two 2D picture here. So you need to make a smooth surface that connect these two picture, which is exactly this hyperbolic parabola. Okay. Okay. Yeah. Huh? I mean, okay. I guess, huh? I mean, we got three lecture doing this. I mean, I mean, okay, but I'm not the course manager. Yeah, if I'm the course manager, then we can say something faster. Ah, see this one. If this one come out, then you die. Okay. I mean, I guess, okay. My attitude is learn first. Learn first. Okay, learn first. Learn first. Okay, learn first. Okay, learn first, huh? Okay, learn first. Okay, learn first. Okay. Yeah, learn first. So yeah. Anyway, wait. Okay, sorry. Come back. Okay. So to imagine about this parabola, right, you should imagine you want to connect these two 3D plane. Okay. Okay. Two diagram is because actually they are the same, right? Can you see it? Okay. Sorry. I mean, they are really the same. Sorry, they are really the same, but maybe I'm too direct. Okay. So so you should imagine how to say. This is like the how to imagine this is like the saddle on the horse. When you sit on the horse, right? There's this seat for you. This is the seat. Okay. So and then if you imagine if you can extend this guy, is really just this thing here. Yeah. So why they focus on this part here? Why they focus on this part is because when you snooze X, right, you will get this hyperbola. Okay, that's why they focus on this shape. Yeah, but really this shape is keep growing up. Keep growing up. So that's why you got the original shape here. Okay. Okay. Yeah. You can think so. Yeah. So but you need to cut it. You need to cut it nicely, only you can get potato chips. Otherwise, you get something else. You need to cut it nicely so that you get potato chips. Potato chips is finite, right? But this one is infinite. I mean, you have to cut it. You know what I mean? You know what I mean by cut it? So you only consider a finite domain. Okay. Yeah. Consider finite domain. Cut it. Okay. Yeah. I think someone make memes on this, right? Potato chips. Yeah. I think. Yeah. Then finally you learn it today. Okay. Yeah, okay, yeah. So maybe potato chips is your motivation to learn this. Okay, all right. Okay, let me see what else we want to do. Okay, we won't do these two. And then so classify these following equations. So maybe I just leave this. Okay, first of all, do you know how to classify the equation? So you need to make it back to this, compare to this 6 equation here. Okay, compare to this 6 equation here. And then decide which one is the surface. Okay, so we left this as exercise. Hey, don't get too excited. Get too excited. Okay, let this as homework. Okay, okay. Let's try. You pick your choice. Pick one. Okay, A. Okay, let's do A. So let's do A, yeah. Okay, so let's observe what do we need to find. So you see, we need to make this x squared, y squared, z squared. Okay, and then we need to get either equals to 1 or equals to some z. Okay, so this is what our goal is. But the first case here is all squared, x squared, y squared, z squared. So we need to make equals to 1. Okay, so it is either 1, 2, 3, either 4 of these. Okay, either 4 of these. So we need to make it either 4 of these because these 4 consists of x squared, y squared, and z squared. Okay, so if it is x squared, y squared, z, then it falls into this category. If it is x squared, y squared, z squared, it falls into these 4. Okay, okay, but your constant is 100, right? So it's not 0. So it's non-zero because for the constant is 0. Okay, but for these 3 ellipses and hyperboloid is 1. So you need to make it 1 first. Okay, so let's make it 1. So how to make it 1? Just now we already have this strategy. Divide by 100. Good. So we divide by 100. Yeah, good. So divide by 100. Yeah, these are little small trick, but it's really crucial. If you don't know how to divide by 100, then you will be in trouble. Okay, so what do you get? Okay, and then you get what? What do you get? You get 2 sign here. So 2 minus sign on xy. What is the shape? Go back and refer to the list. Hyperboloid. So there are 2 hyperboloid, right? There are 2 kinds. So this one is which kind? With 2 sheets. 2 sheets. 2 sheets. Okay, 2 sheets meaning the singularity break off. Okay, singularity break off. Become 2 sheets. So yeah, this is just classifying. If you want to draw, also can. If you want to draw, also can. So this is like something like. So what? I sketch, huh? Okay, I try sketch. Okay, if I try sketch, right? So what's the key information you need to give? First is the general shape. Okay. Second is the intersection. Okay, you need intersect where. So let's draw the general shape first. Okay, something like this. Okay, so you need to find this intersection. What's this intersection? Is at z, right? Z, x equals 0, y equals 0, right? So z is minus 2 or plus 2. Okay, so up here is 0, 0, 2. Down here is 0, 0, minus 2. And then this should be enough to specify what this shape is. Okay, actually this question is not as hard because this is centered at origin. Remember, this 6 type is centered as origin. So we still can do shifted case. Okay. So you can imagine shifted is x minus some S naught y minus y and y naught z minus z naught. Okay, so you can shift. Okay, not only you can shift the center, you also can shift the axis. Okay, so this one will return back to this very complicated form. Okay, otherwise you just need to look at these two. Okay, if you shift origin and then you shift the axis again, then you will get all these cross term coming up. Okay. Okay, I think we've finished this chapter at this point here. Okay. Chapter finished. Okay, we will start a new chapter. No, dismiss, not dismiss. We still have new chapter to go. Very tired, Okay, I give you a water break, 2 minutes. Water break, water break, water break. 5 minutes. Okay, 5 minutes. Okay, whoever want to go toilet, please go, and then we come back for new chapter. Because we have exam, so exam will take out time in class, so we will miss their time. Yeah, we got one quiz and then we got one test, so meaning the 2 days were gone. So we need to like take care of those times. So we have to keep ahead of the schedule. If we are on schedule, then that means we are late because we have tests on those days. So if we are too ahead of the schedule, then we will do exercise in class.
你知道吗？
知道吗？
那一个 time 哦，我的毕总是 online 的嘛。
所以呢，
会占到你的时间，考虑一下。真的，那个谁啊？阿公呢？阿公。
做个 MCO 啊，
不是 MCO，给我们难度高一点点。
难度高一点点嘛。
这个有机会吗？
在 class 就简单一点点。
哦，你做那个太简单，我也说不出来。哦
，OK。
掉了，这两个怎么对的吗？
他们表达一样东西，因为你要把它延长来看。对，如果你一直延长这个东西的话，其实它跟它是一样。
是吗？
是。
就是说这个向下延长变成它这样，然后这个向这边延长变成它。
没有，全部都是一模一样的方向延长，就是他们要向上、向下跟向左、向右的，每个方向他们都要延长。
哦，我知道，但是我的意思说，我肉眼看他们怎么都不大一样。
肉眼看哈，我想一个东西啊，你要肉眼啊，给我想一下啊。OK， 我给你看一个东西，来，我画一个东西给你看，来肉眼看一下这两个会不会一样？
不一样。
但是OK， 这两个其实真的是不一样。等下我再画一个比较贴近的 example。肉眼看哈 ，OK， 不然这样子呢？这样子，我给你另外一个 argument， 就是假设我把这个变大一点呢，把这个延伸来，我可以把这一个放进来，它有没有在它里面？
也就是说，就不看外面它延伸出去的。
对，因为那个也不是它最终的外形。
对，它们其实可以重合的。
Yes， 所以如果我把这个变大，这个我也放得进；把这个变大，这个也可以放得进，明白吗？所以它在它里面，它也在它里面，所以它们的根。
对。
为什么我们要这么画？是为了凸显这些，凸显这些 cross section。
所以它就放两幅图是为了选择性的，一个往这边扩，让你看更清楚，然后一个往这个方向扩。
不是往同一个方向扩，但是你会在那个方向比较清楚的看到这些图形，明白吗？比如你看这个，你不是很清楚看到这个嘛？其实它在里面。所以如果我把它画成这个形式的话，你就会很清楚的看到有这些东西。比如说这个颜色 ，OK， 这一个呢是对于这个很明显，是从这个演到这一个，
不同的 point of view 是
point of view 对，
在不同的 angle 看到的。
不同的一个，
我觉得它是截了
的切面，
对，截了一
切面，就好像我这里看变化跟这里看变化不一样。
但是它还是 x y z 还是这个角度，
它是一模一样的角度，
它是一样的角度，
只是切下去的地方不一样。所以我们每次变成空身的意思就是我在切那个面，就是切那个面。 所以这一个是 for x 跟 y 咯，然后这一个是 for z。
这个地方我不是很理解它是怎么由这个变到这个的。
OK， 这个其实有一个过程的，你写过这个了吗？你可以先把这个写上来。
这个
对，你可以先把这个写上。
它就是这个，
对，没错。
然后 B 的话，
对，没错。
B 的话我就
B 的话
不应该是这个吗？
对，所以你这个要算
哦。
对，这个要算，所以这个是 S0减 X1 S 减 S1减 S0之类。
哦。
对。对，你继续算，你继续算，你可以看到。
但是它没有 X0，就是它没有给出这个呀。
这没事。
你把它带进去就可以解出来。你把那个 D 画到这里面，懂我的意思？
哦，你就是说拿它乘以 D，拿它乘以这个 N。
对，然后你会得到。
可是 D 是什么？
就是
对 D 是
就是
对
后面拿出来的那个，拿出来那些，就那个例子。
对，他讲的是对的，但是你要先写出来，你才知道他在讲。
哦，拿这个乘以这个。
Yes， 没有错。这个不是很像我们一开始在 derive 那个 plane equation，对不对？所以你得到什么？你得到 A 减 A 乘。对，没错。也可以。我们最终 OK 也可以，这样也可以，这样其实更快看得到东西。OK。但是那个部分是什么 ？S0、Y0、Z0是在那个点上面的，对不对？它define 那个 plane equation， 对不对？plane equation 是什么 ？ax 加 yx 加 y 加 by 加 cz 加 d 等于0，所以这个东西等于减 d，
等于0减 d。
0减 d 对，0减 d 咯，就是减 d 咯，所以减 d 变成加，对，加 d 加 d。
但这不是个坐标。这是加。
你还没有 dot with 这个，我们要 dot with 它后来我们还要 dot with 它，我们要考虑 and dot 这个东西。
但是这个东西它不是已经拿这个
了吗？
对，这不是 N 吗？
对，你 dot 了咯，你 dot 了的话，你应该要写，你 dot 了过后，应该这边变成加了。对，变成加，对。
理解。还有就是之前那个 warm up question 就是如果按之前我们没有学polar coordinate 的话，那岂不是我们解出来都是错的？
听不懂。
就是我们这还没有学 polar coordinate 的话，我们肯定只能得出2个答案，但是你说是有4个答案。
其实你去 sign 没有，你其实去 sign 它没有，你其实拿 sign of 那个也是一样。
没有吗？那下面是negative 1吗？这边2个的话你没有讲那里。
你是说，
因为
所以其实那个题目其实有点不 precise， 所以我们的这个 one 其实要在 xy plane 里面。我觉得
就这个 R 和 R 是不一样
对，其实严格来说是不一样，严格来说是不一样。如果我们讨论 r theta plane 上面的 one， 就确实就有2个，但是呢，我们一开始这个课的设定就是这一个是要把它看成 polar graph 所以我们才会自然而然一说 r 等于1，我们就要考虑 xy plane 里面的
xy plane 里面的是
就是 radius e from 那个 origin。
刚刚你画那个圆形是吗？
以前我们的知识量的话，我们是考虑不到的。所以现在我们如果是遇到，
是因为我们一开始的设定的原因，所以我们自然而然就要考虑。是我们 polar graph 的设定有包含这些东西，其实它自然而然会要考虑。
所以只是在这堂课里面我们会考虑
polar graph， 考虑 polar graph 的时候，
那我们也是
在外面，你在外面如果遇到 polar graph，其实你也是要考虑。
就是 polar graph， 不是个坦克，就是 polar graph， 把它看成 polar graph。如果你看，如果把它看成只是那种普通 SY graph 的话，就是普通的。但是我们看成 polar graph 的话，就要，对。
从普通那个角度来考虑的话，它考虑是不全面的。
不是不全面，就是看你在什么情况，如果你在只是 SY 的话就够了，但是如果是在 polar graph 的话就需要。
那如果只是在这个赛来考虑的话，我只能得到2个答案，
对，
就已经是够了，
对，
就已经是正确答案。
对，所以是要看你在什么情况下，在这个情况下，我们是考虑 polar graph 的情况。严格来说，对，没有错。OK。
但是我们以后都要从，
就是看题目了，看题目，看人家问你什么。如果他是在，因为这题其实他是从 polar graph 的角度来问，其实我应该要说 polar graph 来，严格来说。
哦，所以他给个限定词呢？
对，他就是要，对，对，
好，
对，没错。啊？
讲翻 XY 講翻 polar， 就是嚟 XY 同一個 XY 加住 x square plus y square 等於1。如果你換成 polar coordinate， 這樣它的那個在 XY plane 還是 theta
XY plane. 我們的 polar. So there's a question is if I have a curve on x square y square equals to 1, okay, we can plot on xy plane. So if we turn it to r theta polar graph, where does this graph live? So it's still living on xy plane. Okay, just that on xy plane we can put polar axis, okay, or polar coordinate. We're still living on xy plane. Yeah. So this one is actually r theta plane. Okay. So this one is actually r theta plane. Okay. So just now I asked r equals 0. Okay. Why there are 4 points here? Because we care about polar graph. Okay. Polar graph. Because we care about polar graph in xy plane. Okay. So we care about polar graph in xy plane. So that's why we have these 4 different points here. Okay. If we just care about normal graph on r theta plane, there's only 2. So if we only care about normal r theta plane, okay, when r equals to 1, there's only 2 points here. But the setting of the question is we care about this graph as a polar graph in xy plane. Okay, so we need to consider all these 4 different points here. Okay. So there's some subtlety between polar graph, xy graph, xy plane, r theta plane. Okay. Dennis, one more question. Later. Who go and say? Or later no class. Okay. So regarding the schedule, right? We have to keep ahead of the schedule because sometimes we'll miss out due to exam. And then if we can do ahead, we can do more exercises as well. Okay. So this is the plan. Yeah. Yes. No. Don't point at me. Okay. Huh? Okay. You got proof? No. Okay. Let me update you again. Okay. When the questions are ready, I'll update you. Okay. I think don't. I mean, whatever we did in the class, you learn first. Okay. And then, yeah. By the way, in the class, you know. Yeah, continue. Let's continue a bit and then we will stop. Okay. We'll talk about idea first and then we will stop. Okay, next is new chapter. Yes. Chapter 13. Yes. So chapter 13. Okay, let's stop at 55. Okay, 55. 55. Okay. Cannot go other class. I want, but I cannot. Okay, never mind. Okay, wait. Sorry. Come back. So, okay, let's start vector functions. Okay, so vector functions mean so what have you learned? So you learn function from R to R. Okay, so for example, fx equal to x. Okay, from R to R. And then what you learn in the first chapter. Okay, you have parametric equation for curve. Okay, that is you didn't realize, but you are doing R to R2. Okay, R to R2. So you have a t, and then you give xt and yt. Okay, so you write the coordinate in terms of one dimension, which is time. Okay, a literal up to R2, and then this topic here we will learn up to R3. Okay, so for this course, I think the highest dimension is R3. So we just learn up to R3. Yeah, got limit. Okay, so functions. So these are the functions because I give you a time, you give me a position. Vector, because the position can be described using more than two variables. Okay, so x, y, z. Okay, so these are the vector function. So these are called the vector value function. Okay, so what do we mean by vector value? So meaning I give you a number, you give me a vector. Okay, so you give me a number, I give you a vector. So how are these a vector? So if you are more familiar with a column vector, you can see it in this way. But to be consistent, we will use row vector. Okay, to be consistent, we'll use row vector. But to remind you, this is really the column vector. Huh? Yeah, it's linear algebra. So we are combining linear algebra and calculus together. Okay, so we do so the idea of this chapter is we do calculus at every dimension. Yeah, we do calculus at every dimension. If we differentiate or integrate one function here, we integrate all these components, or differentiate all these components, or take limit on all these components. Okay. So, right? Can get me? Cannot? So, okay. So first of all, okay, let me just talk about general idea, then we will stop here. Okay. So in this course, we will take, first of all, we will take limit. Okay, take limit to some other thing. Okay, so in the calculus one, you learn how to take limit on one variable, one dimensional vectors function, and then you also learn how to do differentiation. Okay, you also know how to do integration. Okay, this is what you know, right? So what happened to vector space? Now you got 2 dimensions, you got 3 dimensions. Okay, every dimension you got a function. So you just take limit on all of them, take differentiation on all of them, take integration on all of them. Okay, so you just take limit on. So let me write it in this form. So you take limit on all of them. So maybe t to some b xt, then e to some b yt. Okay, and then you also do differentiation on both of them. And this is what we did last time. Actually, we didn't introduce this, but we'll do it in this chapter. And then you also integrate all of them. Okay. And then similarly, you do it for 3D. Okay, this is the accent of this chapter here. Okay, so instead of doing one variable, 1 to 1 variable, you do 1 to 2, 1 to 3 variable. Okay. Don't want to continue anymore. True. Yeah. Okay, so yeah, so please don't stop learning. Keep going on. We will continue. So remember, okay, this topic. If you remember, you will know what happened for this whole chapter. Okay, remember this one. Okay. I will upload this. Okay, remember this concept here, and then we will talk about in detail next time. 我要我啊，现在你是 OK，去你 OK， 去你 OK， 第6哈，真的吗？第6呀，上课哈，这一个上课哈。什么？我今天没有，我拜4拜5。怎么？我这个呀，你怎样？
现在都是
走了，
走，
你飞上，
你这个没有，
你
在下面的吧？你的啊，好 OK，
我这里算出来了，但是
你算出来了，
你这有问题吗？
我